All right, let's talk about the normal distribution. So key terms, the normal distribution, it is often described as a bell curve, and the parameters that we always need to work with it are the mean and the standard deviations. Since this normal distribution is one of our continuous distributions, the total area under the curve is always going to be 1. Recalling what standard deviation means, remember that standard deviation is a number that measures how far data values are from their mean. So if we go ahead and try to compare the standard deviation of these 3 normal distributions, again, they're normal because they have that bell-shaped form. They are symmetric with respect to the mean, which is the highest peak of the distribution. Standard deviation tells how spread out the normal distribution is. So high standard deviation means the graph will be short and spread out like A and C. They are shorter in terms of the height of the highest peak they have. And then you see how the points are from this point all the way to that point. The spread talks about the distance from the mean to reach like all of the points. A low standard deviation means the graph will be tall and skinny like B. So you see how the distribution goes from this point in here all the way to this point in here. You see how small this area is, but how tall the graph is in terms of the peak. So for all these 3 graphs, A has the largest standard deviation, B has the smallest standard deviation, less spread for the blue one, the B, much more spread for the green, which is the A. Normal distribution are symmetric around the mean. That means that if we go back here, if we draw a line in here, that's going to be the line of symmetry that goes through the mean. The mean, median, and mode of a normal distribution are equal. Remember that when you have a distribution that is skewed, the mean is going to go towards the tail. So the mean is larger or smaller than the median, depending on where your tail is going. The area under the normal curve is always equal to 1, and this is the fact that we use when we are working with probabilities. Normal distributions are always defined by 2 parameters, which are the mean and the standard deviations. All normal distributions have different means and different standard deviations. And then there is something called the standard normal distribution, which is when I standardized all of the values on that normal distribution and I make the mean being 0 and the standard deviation being the mean being 0 and the standard deviation being 1. All right, so when the normal distribution has a mean of 0 and a standard deviation of 1, it is called the standard normal distribution. How do we standardize those values? We use values called Z-scores. The Z-scores, we often talk about them when we talk about the empirical rule. So the Z-scores measure units of standard deviation, is how many standard deviations a value is from its mean. For example, a Z-score of 1.25 means the value is, the X value from our distribution is 1.25 standard deviations to the right of the mean. And we know it's to the right because the Z-score is positive. A Z-score of negative 3.14 means that our original value in the distribution is 3.14 standard deviations to the left of the mean. And it's to the left because the Z-score is negative. If we want to relate standard deviations, mean, Z-scores, and X values, this is the formula that we use for the Z-score. So the Z value equals my value X minus the mean of the distribution over the standard deviation. So let's say that Jerome averages 16 points a game with a standard deviation of 4 points. Suppose Jerome's points per game are normally distributed. X is going to be the number of points per game. Then X, the number of points per game, it's normally distributed with a mean of 16 and a standard deviation of 4. Suppose Jerome scored 10 points in a game on Monday. Then the Z-score when X equals 10 is found using this formula. The Z-score is going to be equal to X is the actual data point, which is 10, minus the mean, which is 16, divided by the standard deviation, which is 4. So then we have 10 minus 16 over 4. That's the same as negative 1.5. So this means that 10 is 1.5 standard deviations to the left of the mean 4. That means of the mean 16. And it's to the left since the Z-score is negative. All right, another example. We can relate mean, standard deviation, and Z-scores once we have, this is the formula. And once you have 3 of them, you can find the 4th one just doing some algebra. So we know that the Z-score of 4, so we have a value, we have the Z-score of 4 tells us that X equals minus 3 is 4 standard deviations to the right of the mean. The standard deviation is 2.5. What is the mean? So if we go back here, this is telling me, and I'll try to highlight as I talk, that this is telling me that this X value here is negative 3, right? This is also telling me that this sigma value here is a standard deviation of 2.5. And this is also telling me that the Z-score is 4. And it's asking me to find the mean. So then when you go back here, you have the Z-score of 4, you have the X value of minus 3, and you have the standard deviation of 2.5. And then when we multiply both sides by 2.5, we have 2.5 times 4, which is 10, equals minus 3 minus mu. And then moving the 3 to the other side makes 13 times negative 1. It means that the quantity that we are trying to find is negative 13. So the mean for this equation is actually negative 13. Right, another example, Karen scores an average of 18 points a game, and her points per game are normally distributed. Suppose Karen scores 12 points in a game, and his value has a Z-score of negative 3. What is the standard deviation for the situation? So then we go here, and again, we have that Karen scores 12 points. So then we have an X equals to 12 in here. We also have that the Z-score is negative 3. So we have the Z-score of negative 3 in here. And in this case, we have an average of 18 points, which is our average, the mean for the distribution. We need to find sigma. So then if we multiply times sigma on both sides, we get negative 3 times sigma equals 12 minus 18, which is negative 6. And then if we divide by minus 3 on both sides, we get a sigma equals to positive 2. So then the standard deviation for this situation is negative 2.